So now let's play with some big numbers. Big odd numbers, big prime odd numbers. Are you scared yet? Same method though. You're just going to go through and list them all, and we're going to go from there. So on this side of the equation, I've got C is 19, H is 17, N is 1, and then my oxygens are kind of funky because I've got 3 here and 2 here, so I've got 5. Over here, I've got 1 carbon, 2 hydrogens, 2 nitrogens, and 3 oxygens. So that side's easier to look at than this one, which means we're going to muck with this one first. You want to be aware of even and uneven numbers. So it's much easier to deal with numbers when they're even because I can break them up easier. I want to make sure that I don't have any numbers that are even on this side and odd on this side, and there's only one of them. So the oxygen's a little bit different because there's oxygens here and here, there's oxygens here and here. It's unclear how it's going to come out in the wash. But H2 is H2. There's always going to be an even number of H's on this side because it's H2. On this side, however, I have H17. So I'm never going to find a common multiple unless I go up. So I'm going to put a 2 in front of this whole thing right away. I know I need to have an even number of hydrogens on this side in order to balance that even number on that side, which is going to change all of these guys, all of them. Let's begin again. 2 19s is 38. 2 17s is 34. 2 n's is just 2. And now I have 2 O3s, which is 6, plus the 2 there, which gives me 8 oxygens. Now, on the same sort of tip, I can see that I have an even number of oxygens here. This one's even, this one's even. This one's even, this one's odd. That means that this number is going to need to be an even number in order to go forward. When I look at what I need to put there, I have 2 groups of 17 hydrogens. I have 2, so I would need to put a 17 here. That's not going to work though, is it? I could try for now, but I'll show you what I mean. Now I have 34 hydrogens, that's lovely, and I have 17 oxygens plus this 2, which is always going to be even, which is always going to make the total uneven. So that's where the problem occurs. Basically what I need to do is make this an even number, but it has to be in the same multiples as this one, which means that I'm going to have to put the 34 here. Now, it might get crazy sometimes, but I'll show you a trick at the end to make sure you didn't get too crazy. Right now we're going to go with it. We've got 34 H2s, which means that I'm going to have to double 34 to 68 to count my H's. And my oxygens are now 34 plus 2, it's kind of funny, is 36 oxygens. I go back to this side and I look at my H's. Obviously, I'm going to have to double this again. So to get to 68 from 17, I have to double 2 and it becomes 4. So that's going to take my 68 here, and it's also going to screw up everything else. So might as well just get rid of those and do it again. Now, 19 times 4 is the same as 20 times 4 minus 4, so we got what, 76? And use a calculator if you get crazy. 4 nitrogens, 4 times 3 is 12, plus this 2 is 14. Sometimes I don't even keep track of the oxygens until the very end, because whatever, it's just going to get fixed. This is my fixer that I'm going to save until the end. Now I've got hydrogens that match. Haven't tried to balance anything else really yet. So let's move on to something else. How about the carbons? Since the carbons are not hydrogen and not oxygen, we can go there. I need 76 carbons on that side. 76 carbons. Wow. Okay, so that changed that to 76. This could be crazy. We could be getting way out of control here, but we're just going to go with it. Now, 76 O2s and 34 oxygens. I'm going to start needing a calculator myself. So 76 times 2 gives me 140, 152 plus 34. So 152 plus 34 gives me 186 oxygens on this side. Wow. That's crazy talk. But we're going to leave it for now. The nitrogens still need to be balanced, and there's 4 nitrogens on this side, so we'll just do that there. That's handy. So that's done. Now, this is balanced, this is balanced, this is balanced, this is not. What I need to do is put a number in front of the oxygen that's going to get me up to 186 in total. Now, remembering that I have 4 O3s here, that's 12 oxygens in this molecule. So 186 minus 12 is going to get me 174. I need 174 oxygens in here, but it's O2. So I'm going to have to divide 174 by 2 and figure out what that is. Now, 187. I'm just going to run my calculator to make sure, but I'm pretty sure that I'm not wrong there. 174 divided by 2 gets me 87. And here we have an uneven number. I'll tell you why that's significant. These numbers are crazy high. Lots of times if you get an equation like this where you kind of went, oh, crazy, you got them all balanced, but the numbers seem really high. Did you go too high? What you want to look for is there a common factor I can reduce all these numbers by? And if they're all even numbers, then obviously you can, right? If this was 86, I could take at least a 2 out of everything and reduce it back down. So don't be afraid to use big numbers, because we can always look at the final result and see if we can reduce them, just like you'd reduce a fraction. However, in this situation, I have an 87. 87 is a bad number. It doesn't have a lot of factors, and it is not an even number. So this is my smallest number. I could only ever reduce this entire thing by the smallest number, right? Because if I reduce this by 2, it becomes 1, it's done. It can't reduce anymore. So the only possible number I could reduce all these big numbers by is the smallest one, which is 2. I cannot reduce 87 by 2, and therefore, this is balanced. It's big, it's crazy, it's a little bit wild. Whoops, guess I better change that one just to make it official.